Have you ever grappled with an old system, maybe an appliance or even some software, where everything feels just locked together,
Mhm.
hardwired?
Yeah.
Like you try to swap out one tiny part and find out you basically have to rebuild the whole thing.
Yeah.
Yeah, super frustrating. And in software where things need to change, that kind of rigidity is a killer. It
Yeah.
leads to code that's just brittle, hard to manage. So today, we're diving into a really powerful idea that tackles this head on. Dependency injection, or DI for short.
Absolutely. And our mission, really, in the deep dive, is to unpack what DI is all about, its purpose, why it's so important, its impact. We're drawing on these sources you've gathered. It's not just the what, but the why. Why did it become so crucial, especially now? Honestly, getting DI is like getting a key to understanding how modern, flexible software gets built.
Okay, let's jump right in then. So at its heart, DI is trying to solve that core problem, right? How do you build complex stuff where pieces need to work together, but you also need to swap them out easily? For ages, the way it worked was, well, one part of the code just made the other parts it needed, like a shopping cart creating its own payment processor inside its own code.
Exactly. And that direct creation, that's what we call tight coupling. It was a massive problem. Using your example, if the shopping cart makes its own PayPal payment gateway, what happens when you want to switch to Stripe? Or add, say, a new tax calculator? You'd have to dig right into the shopping cart code itself and change how it creates and uses that payment part. Dependency injection just flips that completely. Instead of a component creating its dependencies, those dependencies are, well, given to it. They're provided from somewhere else.
Okay, so a dependency is just something another piece of code needs to work. Like the shopping cart needs a payment gateway. And DI is the act of handing that payment gateway to the shopping cart instead of the cart building its own.
Precisely. Think about it. The shopping cart, its main job is managing items, calculating totals. It doesn't really need to know how the payment gets processed, just that it does get processed. So DI lets the shopping cart just say, hey, I need something that can handle payments. And then something else, usually a DI framework says, okay, here you go, and gives it the right one.
Right, like a central manager or something?
Yeah, sort of like a central registry.
Yeah.
It knows what components are available. Maybe it's PayPal today, Stripe tomorrow, and how to connect them. The shopping cart just gets what it needs and focuses on its job.
That's a really interesting shift in responsibility. It's not just passing objects around. It's like the framework takes on the burden of wiring things up.
Mhm.
So the developer writing the shopping cart doesn't have to worry about how the payment gateway is created, just that they'll get one. It's
Mhm.
building with flexibility from the start, like Lego bricks, maybe?
That Lego analogy is pretty good, actually. You can snap pieces together, swap them out, reuse them without having to break the whole thing apart. And that shift, that modularity, is why DI isn't just some academic concept. It's fundamental to how we build software now. It solves so many real-world headaches.
Okay, let's get into those headaches, because understanding the before picture really shows why DI was such a breakthrough. What were the big problems it solved? You mentioned tight coupling already.
Yeah, that was a huge one. Like
Or
we said, if shopping cart directly creates new PayPal payment gateway, they're stuck together. Any change in PayPal or wanting to add another payment option meant changing the shopping cart itself. DI breaks that link, it decouples them. The shopping cart just asks for a payment gateway interface. The actual concrete thing, PayPal or Stripe or whatever, gets plugged in later. So the shopping cart code doesn't even know which one it's talking to. That makes it way more flexible.
that makes sense. It decouples things, makes the code more resilient. And I bet that helps with testing, too, because testing those tightly coupled things must have been a nightmare.
Oh, absolutely. Difficult testing was a major pain point. If your shopping cart always needed a real PayPal connection to run, your tests would need internet, a real account. It was slow, unreliable, sometimes expensive.
Right, you couldn't just test the cart logic easily.
Exactly. But with DI, since this shopping cart just receives a payment gateway, during tests you can just inject a fake one, a mock object. This fake gateway doesn't need internet, it just pretends to succeed or fail instantly. Your tests become super fast, totally reliable, and repeatable. It's a massive win for quality.
Okay, that's a huge practical benefit. Faster feedback, more reliable tests. And I guess this flows into fixing code maintenance challenges, too. Big tangled systems are scary to change.
For sure. When everything's interconnected rigidly, changing one thing can break something totally unexpected somewhere else. You get these ripple effects. DI promotes modularity. Components are loosely connected like self-contained units. So if you update or replace one part, like maybe a reporting module, the change stays contained. Less risk of introducing new bugs, less time spent fixing things.
And I imagine that problem just gets worse as applications get bigger. Which brings up scalability issues. Was it hard to grow applications without DI?
Definitely. Adding significant new features to a big, monolithic, tightly coupled app often felt like open heart surgery. You had to carefully modify large parts of the existing system. DI's modular approach inherently supports scaling. Often you can add new features as completely new, independent components that just get injected where needed. Think about adding, I don't know, a new recommendation engine to a streaming site. With DI, it's potentially just a new module you plug in, not a rewrite of half the platform. Makes growth much more manageable.
Which must ultimately boost developer productivity, right? Because developers aren't spending all their time just managing connections and untangling code.
Exactly. Before DI frameworks became common, there was a lot of manual setup. Developers spent real time writing code just to create and connect all the different pieces. Modern DI frameworks automate almost all of that. They handle the object creation, the wiring, so developers can focus their brainpower on actually building the features, solving the business problems, not plumbing. And if we zoom out a bit, look at the bigger picture today, in 2025, DI isn't just nice to have, it's pretty much essential. It's a pillar of modern software development. Its importance has just grown because of how we build things now, the demands of the industry.
Yeah, you can really see that with things like microservices and cloud computing. Modern apps are often broken down into these small, independent services talking to each other. DI seems tailor-made for that, doesn't it? Each little service can just declare what it needs, and the platform or framework provides it without hardwiring services together. It works really well with cloud platforms too, like AWS or Google Cloud.
Absolutely critical for microservices. And it directly feeds into enabling web development. Businesses need to move fast. Startups, big companies, everyone. DI cuts out so much manual configuration and setup that startup building a delivery app, they can use DI to quickly wire up order processing, payments, driver tracking, maybe swap providers later if needed. It just accelerates getting to market.
And speed is great, but you also need reliability. So improving software quality must be a big factor too. We talked about testing, being able to easily inject mocks for thorough testing is huge, especially in critical systems like medical software or financial apps where a bug could be really serious. You can test edge cases with fake data reliably.
Definitely. Quality goes way up. Plus, DI is basically built into so many modern frameworks. If you're working with Java, you're probably using Spring or Spring Boot. Web development.
Yeah.
Angular, Nest.js. They all rely heavily on DI. So learning DI isn't just learning a pattern, it's learning the way these incredibly popular, powerful tools work. It makes you much more effective and, frankly, employable.
That's a great point. It's become industry standard.
Mm.
And it also seems like it helps future-proof things, right? With adapting to changing technologies, tech never stands still.
Exactly. A new database technology comes out, a better third-party API for some service you use. With DI, swapping out the old component for a new one can be relatively painless. You're just changing which implementation gets injected. The core application logic might not need to change much at all. It lets your software evolve instead of becoming obsolete or needing a massive rewrite every few years. It builds in adaptability.
Okay, so bringing this back to someone maybe just starting out, learning to code, what does all this mean for you? Why should a beginner care about dependency injection? It sounds kind of advanced.
Well, paradoxically, it can actually create an easier learning curve in some ways. Because these DI frameworks handle so much complexity for you. You can start building a web application that talks to a database without having to first become an expert in manually managing database connections or transaction scopes. The framework, using DI, smooths over a lot of that initial complexity.
So you can focus on the application logic first.
Right. And then there are the job opportunities. Like we said, this is standard practice. Google, Amazon, Netflix, banks, startups. Pretty much everyone building significant software uses DI in some form. Knowing it is a huge plus. It's a skill employers look for across many different roles. And even for your own smaller projects, maybe a portfolio piece or just something for fun, using DI helps you in building better projects, even a simple to-do list app or a personal blog. DI encourages you to think in terms of modules from the start. It makes your code cleaner, easier to test, easier to add features to later. You might build a comment component for your blog that you can then easily reuse somewhere else. And fundamentally, learning DI is about preparing for the future. It underpins so much of modern software architecture: microservices, serverless, cloud-native apps. Even getting into AI or IoT systems often involves components getting their dependencies injected. It's a foundational skill for where the industry is going.
That makes a lot of sense. So someone listening is thinking, okay, I'm sold. How do I learn this? What are the practical steps? Our sources had some good pointers. First, start simple. Find some beginner tutorials, places like Free Code Camp, maybe YouTube channels focusing on specific languages. Build something small where DI helps, but isn't overwhelming.
Yeah, definitely start small. Then maybe pick a popular framework that uses DI heavily and work through its official tutorials. Spring Boot for Java is a classic example. Angular or Nest.js for TypeScript, JavaScript. Their own websites, like spring.io, usually have great getting started guides.
Good idea. And then just practice, right? Build
Yeah.
your own small projects, maybe that budget tracker or a recipe app. Actively think about, okay, what are the different pieces here? How can DI connect them?
Exactly. Hands-on is key. And don't be afraid to use online communities. Stack Overflow is obvious, but also Reddit forums for specific languages or frameworks. See how others solve problems, ask questions when you get stuck. It's a great way to learn. So yeah, to kind of wrap it up, dependency injection it's elegant, really. It's this powerful idea that lets us build software that's flexible, that we can actually test properly, and that's way easier to maintain over time. It directly tackles those old problems of code being too tangled, too rigid, making everything from testing to scaling a real challenge.
And looking around now in 2025, its importance is just undeniable. With microservices everywhere, the need for speed, the focus on quality, DI is kind of the unsung hero enabling a lot of it. It's working behind the scenes and tools and systems used by pretty much every tech company, big or small. So maybe something to think about as we finish up. Look at the apps you use every single day, streaming, banking, social media, whatever it is. How many of them rely on being flexible, on being updated constantly, on having different parts work together seamlessly? That's the world DI helps build. And maybe consider, how could thinking in this modular, flexible way, this dependency injection way of thinking, apply to how you solve problems? Even outside of writing code, where else is adaptability key?